Hello, everyone. My name is Mark Hiner, and I'll be giving this year's technical update for our team at the Laboratory for Optical and Computational Instrumentation under Kevin Ellisiri. I wanted to talk first about how we see the role of LOCI in the overall ImageJ community. We are funded in part by the NIH P41 COBA grant. That drives a portion of our work. We are maintainers of ImageJ 2 in Fiji, many of the plugins that extend them, and the SciJava libraries that support them. And we are always looking for ways to bridge our Java-based software with other tools that are important in the image analysis community. Before talking about individual projects, I wanted to talk about ImageJ nomenclature. So ImageJ as an application refers to the application developed by Wayne Rasband. Other uses of ImageJ include contexts such as ImageJ 2 for the application developed at LOCI, or the ImageJ ecosystem, which includes both applications. So Fiji is another part of this ecosystem. It's a distribution of ImageJ that includes the ImageJ and ImageJ 2 applications and plugins for both. In documentation, you may see ImageJ 1.x, which refers to the ImageJ application as well, but includes just the versioning system employed by Wayne Rasband. For developers, we want to let you know that the Mavenized source code for ImageJ and ImageJ 2 applications are now in the appropriately named GitHub repositories under the ImageJ organization. So our hope is that this change makes it clear and easy to find the project that you're looking for. So Python is a primary target when we talk about building bridges to other environments. And PyImageJ underpins a lot of our efforts here. So I wanted to talk about what PyImageJ actually is, a collection of Python libraries working together. At the lowest level, we have Jago, which is used to collect the Java side of things that we want to interface with from Python. JPipe is the technology that we use to manage that Java-Python interface. SciJava adds on some utility and convenience for interacting with the lower layers. And imglib manages the data structure conversion going between NumPy and imglib2 images. And then PyImageJ is at the top, and that provides the application level interface and an entry point. So as a new user, you would want to start with the PyImageJ documentation, which is available on GitHub and PyPy. RunImageJ script is one of our projects built on PyImageJ. This is a CellProfiler module that can read in a SciJava script that has annotated inputs and outputs and maps these to CellProfiler settings, allowing the user to include the script in their workflow. The CellProfiler is written in Python, so conversion across languages is handled by PyImageJ. And because we're working with scripts, we don't have the granularity of exposed ImageJ, of individual ImageJ2 commands, but the functionality is all still there. So this is available now in CellProfiler plugins, which does require building CellProfilers from source to use, but there are instructions in the GitHub repository. Another of our Python projects is napari-imagej. So similar to runImageJ script, we are exposing ImageJ2 commands, but within Napari. So this is still in development, but it gives us a ImageJ2 style search bar where you can find a command of interest. Selecting a command, you get another widget that shows available actions. And finally, we have a widget for assigning inputs and outputs. So image inputs are then taken from the Napari layers, but the rest are entered manually. So moving out of Python to Java, one of our main Java efforts this year has been Ops. So I wanted to talk about what Ops actually is. So Ops is a way for algorithms to be plugins. If a plugin is a discoverable piece of code, and an algorithm is a function with typed inputs and outputs, then an op is a discoverable typed function. And the ops framework determines how ops are defined and matched to a caller's request for an algorithm. So we are creating SciJava Ops because basically it was too hard to add ops to the original ImageJ ops, which is the V1 framework. And the V1 ops is not really powerful enough to make it compelling. So, for example, these are the features that are driving now the development of SciJava Ops. Now, if you're interested in SciJava Ops, you can follow along with what work has been done through the project board or through the high-level view of ops pull requests. The work itself takes place in the SciJava Incubator, which is our test bed for developing new projects in tandem. On the community side of things, this past year, we migrated the ImageJ wiki from a media wiki-based format to GitHub pages. So we had an event last year where the great Wiki launch, where community members came together to help us vet pages from the old wiki that were auto-converted to the new GitHub pages format. And as a community, we got up through about half of all the pages being vetted. So you can easily identify which pages on the wiki have not been vetted yet. This is just a matter of comparing the old and the new page and make sure that the formatting still looks the same. We would love to get more help getting this remaining page count down to 0. And even though we're on GitHub pages, the ImageJ wiki is still a wiki. So each page has an edit this link, and it will just take you to GitHub to make the changes there. On the testing and deployment side, so we migrated all of LOCI's projects from Travis to GitHub Actions for continuous integration. If you're interested, anyone can use this infrastructure for their repository. You just run the Actionify script from SciJava scripts. And you will also have to do a one-time organization level setup of secrets, but just talk to us and we can help set those up for you. So finally, I want to talk about what our priorities are going into 2023. On the development side, we want to finish up SciJava Ops and the V2 of ImageJ Ops. We want to get napari-imagej released and into users' hands. We want to improve PylmageJ, which works well when calling Java from Python, but requires more work in the Python from Java direction. So for example, connecting to the SciJava script editor within Fiji. We also want to repair our remote tools, ImageJ Omero and ImageJ Server. So looking at infrastructure, we want to redesign the ImageJ updater to a Maven-based product to improve reproducibility and simplicity. We want to update to Java 17 and make it easier to update to new Java versions in the future. Also, we would like to automate our melting pot test suite to ensure that all of our libraries still play nicely together as dependencies change over time. And on the community side, we want to improve status SciJava page with a clear overview of basically what attention is needed for individuals at all levels of the plugin lifecycle. We want to improve Java generation to be fully reproducible and in a way that's compatible with the SciJava Maven repository that we host. And we want to improve the wiki search functionality to include code searching and more. So finally, we just want to thank everyone who's been involved with these projects, who has helped us connect with the external projects, our funding sources, all the wiki contributors, and thanks to all you listeners today for your interest.